Hello all, this is Dr. Srilatha working as Senior Assistant Professor in the Department of Mathematics in Vallurupalli Nageshwara VIGNANA JYOTHI Institute of Engineering and Technology, Hyderabad. Today I am going to explain about how to find inverse of a matrix by using Gauss-Jordan method, and we'll do some example problems. After that we move on to Introduction to System of Equations. Now coming to finding how to find this inverse of a matrix by using Gauss-Jordan method, we'll be having working rule here. Now first step is, suppose capital A is a non-singular matrix of order n. So whatever may be the order here, it may be of 3 by 3, 4 by 4, 5 by 5, like that up to so on. The first step is we need to write the given matrix which is in the form capital A equal to identity matrix of order n. So here I suffix n is nothing but n denotes the order of the matrix. If we are having order of the matrix is 4 by 4, and here we will allocate small n is equal to 4. If our order of the matrix is 5 by 5, we will allocate n is equal to 5. So here we will write A is equal to identity matrix of order n into capital A. So when we move on to the step 2 here, so whenever we'll convert this given matrix into identity matrix, here we'll apply only row operations. So here we'll apply elementary row operations only to the matrix capital A in LHS and prefactor matrix of, that is identity matrix of order n in RHS. So here we will be doing this equation, that is we'll be operating this elementary row operations until we get an equation which is in the form identity matrix of order n, which is equal to, now our identity matrix is converted into some capital B matrix multiplied with A. So here capital B is nothing but the inverse of the given matrix capital A. Let me take one example here. Suppose my matrix which is in the form capital A is equal to, let I am taking any 3 by 3 matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is the order of this matrix here? 3 by 3 order. So what is the first rule? We need to convert this matrix if you want to find out the inverse here. I will be writing the given matrix A is equal to identity matrix of order n. So what is our order here? N is equal to 3. So I suffix 3 multiplied with A. So here we'll be writing the given matrix here 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we need to write the identity matrix of order 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1 and multiplied with A. So here we'll be implementing the elementary row operations only for the diagonal element. The first step is with the help of this element, I need to make the down elements equal to zeros with the help of row operations. So whatever the row operations we will be implementing in LHS, and same row operations we will be implementing for the prefactor matrix under RHS, right? And the second step is with the help of this A22 element, I need to make the above and the below element are all equal to zeros with the help of row operation. Again, this same operations we will be implementing to the prefactor matrix, that is identity matrix, to in RHS. And the third step is with the help of this element, I need to make all above elements are equal to zeros with the help of row operations. And same operations we will be implementing here in RHS. So that's the reason here we will convert this matrix into any identity matrix of order n, and this matrix is going to be capital B and this is A. So here what we are saying here, this capital B is the inverse of the given matrix capital A. So we will do one example problem here. So we are having one example finding the inverse of the matrix capital A using Gauss-Jordan method. So as we all know, this is the given matrix of order. What is the order of the matrix here? This is the order of the matrix is 4 by 4 matrix. So here the first step we write the given matrix in the form capital A is equal to identity matrix of order n into capital A. So what is my order of the matrix here? This is 4 by 4. That means n is equal to 4. So here we'll write capital A is equal to identity matrix of order 4 into capital A. So here what is capital A here? I will be writing the given matrix minus 1, minus 3, 3, minus 1, 1, 1, minus 1, 0, 2, minus 5, 2, minus 3, and minus 1, 1, 0, 1. So this is the given matrix of order 4 by 4, which is equal to, now here we will be writing our identity matrix of order 4 by 4 matrix. What is identity matrix of order 4 by 4? 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1 and multiplied with capital A. Now what is the first step here? We will apply row operations on matrix A in LHS, and same operations will be implementing on identity matrix of order 4 in RHS until we reach the result I suffix 4 is equal to capital B into A. So here obviously what we'll be calling here, then capital B is the inverse of capital A. So now we move to next step here. So if I want to make the elements here with the help of this A11 element, I need to make all down elements equal to zeros with the help of only elementary row operations. Now what is the first operation I need to implement here? With the help of this R2, I need to make, with the help of this R1, I need to make the R2 element equal to 0. So here R2 tends to R2 plus R1. So that 1 minus 1, 0. Next R3 tends to, here I am having 2 and this is minus 1. Now multiplying minus 1 with 2, this becomes minus 2. Now R3 tends to R3 minus R1. So the 2 minus 2, which is equal to 0. Next R4 tends to, so here we are having minus 1 and this is plus 1. R4 minus 1 minus R1. So this becomes 0. Now we will apply the corresponding operations here. So now applying R2 tends to R2 plus R1 and R3 tends to R3 plus 2 R1 and R4 tends to R4 minus R1. Now I will be writing my first row as it is, minus 1, minus 3, 3, minus 1. Now this is going to be 0. Now I will be implementing the same operation to second row here so that it becomes minus 2, 2, minus 1. And this is also going to be 0. And now I will be implementing the same operation to third row here. I will be getting the corresponding elements. And this is also going to be 0. And I will be implementing same operation to fourth row, that is R4 minus R1, which is equal to same operations I will be implementing the identity matrix in RHS. I will be writing the first row as it is. Now implement here. This is 1, 1, 0, 0. And now here 2, 0, 1, 0. Minus 1, 0, 0, 1. So my first step is completed, that is with the help of this A11 I did all the down elements equal to 0. And my second step is with the help of this element I need to make the down elements and the above element are equal to zeros. Now what are the row operations I need to implement here? Now applying R1 tends to, so multiply this with 2 and that with 3. 2R1 minus 3R2. Next R3 tends to, here I am having 11 and this is 2. Now multiply this with 2, 2R3 minus 11R2. Now R4 tends to, here I am having 4 and this is minus 2. R4 plus 2R2. So here the first row, now 2R1, that is minus 2 minus 0, minus 2. Now this becomes 0. And here 3 to the 6, 6 minus 6, this is also 0, 1. I will be writing as it is because I am not implementing any operation to second row. I am writing as it is. Next R3, 2 R3 minus, now this is going to be 0 and this is 16 minus 22 minus 6 and this is 1. Now this is also 0. Now this is going to be 0 and R4 plus 2 R2 and this is 1, 0. So which is equal to, same I will be implementing the operations. 2R1 minus 3R2, that is 2 minus 3 minus 1 minus 3 0 0. I will be writing the second row elements as it is 1 1 0 0. And we need to implement R3 tends to, this is minus 7 minus 11 2 0. and this is 1, 2, 0, 1. So whatever the operations we'll be implementing to the LHS, same operations we need to implement for RHS. So I completed 2 steps, and my third step is, with the help of this element, I need to make above all elements are zeros and below element are equal to zeros. Now what are the operations I need to implement here? So the first element is automatically 0. No need to perform any operation here. Now moving to second, R2 tends to, now I'm having -6 and here 2. R2 tends to 3 R2 plus R3, and R4 tends to, here I'm having 6 and this is 1. Now multiplying this with 6, R4 plus R3. So these two operations we need to implement both in LHS and RHS. So the first row elements becomes -2, 0, 0, 1, and this becomes 0, -6, 0, -2, 0, 0, -6, 1. So whatever the operations we will be implementing, same operations you need to implement to the middle elements, that is -1, -3, 0, 0, and -4, -8, 2, 0, -7, -11, 2, 0, -1, 1, 2, 6. So I completed my third step here. Now moving on to fourth step with the help of this element, that is, I need to make all above elements are all equal to zeros. Now what are the operations I need to implement here? Now applying R1 tends to R1 minus R4, that is 1 minus 1, which is equal to 0. Now R2 tends to R2, that is -2. Now plus 2 R4, -2 plus 2 plus becomes 0. And R3 tends to R3 minus R4, 1 minus 1, which is equal to 0. Now R1 minus R4, that is -2, 0, 0. Now this is going to be 0. Next, this is 0, -6, 0. Now this is going to be 0. And this is 0, 0, -6. Now this is going to be 0. Now we'll be writing the fourth row as it is. Now applying the same operations to the prefactor matrix, that is in RHS, R1 minus R4, and this is going to be 0, -4, -2, and -6. Next, R2 tends to R2 plus 2R4, -4, -2, -6, -6, 6, 12. Now R3 minus R4, -6, 12, sorry, -12, 0, and this is -6, -1, 1, 2, 6. So now, if you observe the diagonal elements, you are having -2, -6, -6. Now we need to convert this into 1. Now applying R1 tends to R1 divided by -2, R2 tends to R2 divided by -6, and R3 tends to R3 divided by -6. Now what we are going to get here? 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 1. Did we converted the LHS, whatever the given matrix, we converted into identity matrix here. Now apply the operation R1 divided by -2. This is 0, 2, 1, 3. And R2 divided by -6, 1, 1, -1, -2. R3 divided by -6, 1, 2, 0, 1. So you can write this fourth row as it is. Now we converted the given matrix into identity matrix of this matrix, that is, so this is a matrix of identity matrix of order 4 by 4, and we'll be calling this matrix as capital B. Now we'll write this is in the form identity matrix order 4 by 4, which is equal to capital B into A. Therefore, the inverse of a matrix A inverse, that is capital B, is equal to 0, 2, 1, 3, 1, 1, -1, -2, 1, 2, 0, 1, and -1, 1, 2, 6. So which we got the inverse of the matrix by using the above steps. So what are the steps we followed here to convert the given matrix? So first we wrote the given equation which is in the form A is equal to identity matrix of order multiplied with A. And whatever the row operations we are implementing in RHS, the same operations will be implemented for identity matrix in RHS. So by following the step-by-step procedure, we converted the LHS part whole matrix into the identity matrix of order 4, which we'll be getting in RHS as capital B multiplied with A, where A inverse is nothing but the capital B matrix, which we'll be calling this as inverse of the given matrix. So whatever may be the example problems for finding how to find the inverse of a matrix by using Gauss-Jordan method means, so you need to keep in mind only we will be implementing here only row transformations. With the help of these row transformations, we'll be converting and we'll be finding the given inverse of a matrix. I hope you understand this method. Now moving on to the introduction of the system of linear equations. As you all know, you'll be studying this system of linear equations in your LS school onwards. But when you enter into this engineering, so whatever the applications we'll be having here, so here system of linear equations are converted into two different categories. One is non-homogeneous system of equations. Second one is homogeneous system of equations. Now first we'll consider the set of equations that is related to non-homogeneous. What do we mean by non-homogeneous? The RHS. So suppose you will be having the equation which is in the form a1x plus b1y plus c1z equal to d1. So if you are having this d1, the constants in RHS, we'll be calling this equation as non-homogeneous system of equations. Suppose you are having in place of d1, if you are having 0, in that case, we'll be calling that equation as homogeneous system of equations. So here we are having three different equations in our hand. a2x plus b2y plus c2z is equal to d2. a3x plus b3y plus c3z is equal to d3. Now the first step is we'll be writing the given system of equations that is in the form capital AX is equal to B. You'll be writing given equations in the form matrix form here. So what are the coefficients of capital X here? Coefficients of Y, coefficients of Z. A1, B1, C1, A2, B2, C2, A3, B3, C3, and with respect to the constants here you're having 3 x, y, z with respect to the constant d1, d2, d3. So which is in the form Ax is equal to capital B. Now here we need to define the augmented matrix. So here augmented matrix is generated by A given B. We'll be writing the capital A matrix along with the constant matrix. So we'll be calling that matrix as the augmented matrix. So here we need to keep in mind some conditions whenever we need to do the consistency conditions here. Now we know the definition of augmented matrix which is generated by A by B. Now we need to reduce this augmented matrix into echelon form, as we already know how to find the matrix, that is how to find the rank of a matrix by using echelon form. Same applying the same procedure. Again we need to convert this augmented matrix into row echelon form. Next we need to find the corresponding ranks as rank of A, rank of augmented matrix. That means if rank of A is not equal to rank of augmented matrix, in that case the system is said to be inconsistent. If the system is inconsistent means it has no solution. If suppose another condition, if rank of A is equal to rank of augmented matrix, in that case we can say that the system is going to be consistent. If it is consistent means it has a solution. If it has a solution means what type of solution we will be getting? Is it unique solution or infinite number of solutions? Next we move on to next condition here. If rank of augmented matrix equal to rank of A and this is also equal to number of unknowns. If all these three conditions, if all these three are equal, in that case we can say that the given system is going to be consistent and it has a unique solution. And the second condition is if rank of augmented matrix equal to rank of A but it is less than the number of unknowns. In that case the system has infinitely number of solutions or infinitely many solutions. So whenever we need to solve the system of equations under non-homogeneous, you need to define a augmented matrix, then you need to keep in mind all these rules. So when the system is going to be consistent, if rank of augmented matrix equal to rank of A, if the both values are equal, we can say that the system is consistent. If the system is consistent means it has a solution. It has a solution means what type of solution? Is it infinite solution or the unique solution? Again we need to move back to the number of unknowns. If rank of augmented matrix equal to rank of A equal to number of unknowns, if all these three values are equal, in that case we can say that the system has unique solution. And the another condition is if rank of augmented matrix equal to rank of A, but it is less than number of unknowns. In that case, the system of equations will have infinitely many solutions. Next, as I said earlier, we are having the system of equations two categories. One is non-homogeneous, another one is homogeneous. Just now we completed the non-homogeneous. Now we move to homogeneous system of linear equations. So always we'll be writing given system of equations that is in the form capital Ax equal to 0. So again, we'll be having always homogeneous system of equations are consistent. Always it has a solution. Now we need to check what type of solution we're having, whether it has a zero solution or trivial solution or non-zero solution, right? So when again here, if you're finding here rank of a matrix and the number of variables are R is nothing but the R stands for rank of the given matrix and N stands for the number of unknowns. If these both values are equal, in that case, the homogeneous system of equations will have a unique solution. If R is less than N, the rank is less than number of unknowns. In that case, we'll be having infinite solutions, right? So here, always we'll be talking about it may be singular or non-singular matrices here. So coming to the homogeneous system of equations, we'll be calling capital Ax equal to 0 means either we'll be having a zero solution or we'll be calling this as a trivial solution. Other than this, another solution will be called a non-trivial solution or non-zero solution. So how can you find the non-zero solution or the infinitely many solutions means we need to choose n minus r independent solutions. Independent where n stands for number of variables and r is the rank of the matrix. So suppose I'm having in my hand small n is equal to 4 and the rank I got it as 3. If I want to find out n minus r, that is 4 minus 3, which is equal to 1. That means I need to choose this one arbitrary constant. You may take any arbitrary either x for y or z. You may take any arbitrary constant here. I am taking k is any arbitrary constant. So using this condition, we may calculate the remaining solutions in terms of k itself. So how we will be saying this is an infinitely many solutions when for the k values, if you're going on giving the values k is equal to 1, 2, 3 like that up to so on. For k equal to 1, you will be getting one solution. For k equal to 2, you will be getting another solution. And for k equal to 3, you will be getting another solution. Suppose 2k minus 1 and this is k. So for different values of k, we'll be getting infinitely many solutions. So this is the brief about non-homogeneous and homogeneous system of equations. I hope you understand this one. We will continue this video in another form. So what are the problems behind the non-homogeneous system of equations and the homogeneous system of equations? How you will be getting this unique or the infinite solutions or the consistent or inconsistent? We'll be having another in another video. We'll be watching the problems here. I hope everyone understood this one here. Thank you all. Thank you for watching.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.